In this video, we'll be familiarizing ourselves with the applications of integration. So, integration can be primarily used in three ways: getting the area of a curve, or getting the area under a curve, getting the volume of a curve, and obviously in kinematics. So, let's look at the area under a curve. Now, there is a derivation process for this, but it's quite complicated, and hence I'll just jump into the formula of getting the area under the curve. So suppose you've got a curve of y is equal to f of x. The curve is y is equal to f of x. This is the y-axis, this is the x-axis. This is b and this is a. So these are values of a and b along the x-axis. What we have to do is get the area under the curve y equal to f of x enclosed by this region a and b. So we're actually looking for this area. So how do we do this? So there's a formula which we use to get this, and the formula goes like this: you integrate f of x, or the equation of the curve, with the limits a and b with respect to x. If you do this, you're going to get the area of the curve you're going to get the area under the curve in that region. So let's do an example. We are asked to find the area under the curve y equal to 2 plus x squared, the x-axis, and the lines x equal to 1 and x equal to 3. First of all, let's sketch this curve. So if you don't know how to sketch this curve, or if you're not comfortable sketching it manually, you can use your graphical display calculator. So sketching the curve y equal to 2 plus x squared would give you something like this. So this is the point 2, or is the same as the y-intercept, and if your value of x is equal to 1 is here and your value of x equal to 3 is over here, what we're actually doing is, if I were to just continue this curve, we are finding the area of this region which I'm just gonna shade right now. So this region will be the area which you're finding. So this is the curve, the red line, that's the curve y equal to 2 plus x squared. When x equal to 1, you have some specific y value, and when x equal to 3, you have another specific y value. I'm just drawing this graph as a rough graph so that you know what you need to actually find, but you can actually solve this question without drawing the graph. So this is the area which we're looking for. Between x equal to 1 and x equal to 3, you're looking at that area. Also, we are given the x-axis. So this is the x-axis, hence you're looking for the area which comes towards the x-axis. Suppose if it was the y-axis, you would have been looking at an area that comes towards the y-axis, but this is x-axis. So you look at an area that comes towards the x-axis. Again, if we were to apply the formula we learned above, this one, the area is equal to the integral of b and a. So x equal to 1 and x equal to 3 are our b and a's. So 3 will be on top and 1 will be at the bottom, and then you integrate 2 plus x squared with respect to x. Very simple. Just do the normal way: 2x plus x cubed over 3, and you take 3 and 1 as your limits. Again, you substitute this in the calculator. So 2 into 3 plus 3 cubed divided by 3 minus 2 into 1 plus 1 cubed divided by 3. And so by getting these values, your answer is 38 over 3 units squared. Note that the area is the absolute value of the function. So if you get something like minus 35 units, just make it positive 35 units. That will be your area. Hence, take the modulus of your answer.